Okay, let's dive right into this explainer. Today, we're tackling a reality that pretty much every modern organization is wrestling with. And honestly, it's kind of the biggest bottleneck in tech right now. Look, companies are literally wasting millions of dollars trying to force advanced AI into environments that simply aren't ready for it. You just can't bolt an artificial intelligence strategy onto a broken, outdated data stack and expect magic to happen. It just doesn't work that way. Successful AI is entirely, 100% dependent on having a robust, well-governed, and real-time data infrastructure.
So you might be wondering, what actually happens when your AI learns from bad data? Well, it's a completely chaotic reality. If you feed a large language model inconsistent, outdated, or just plain flawed training data, it doesn't just repeat those errors, it absolutely amplifies them. Imagine rolling out a customer service bot that confidently gives your clients disastrous financial advice just because it pulled info from some old, ungoverned spreadsheet. We're talking about extreme hallucinations and completely unreliable outputs. And on top of that, if you're operating under strict compliance laws, like the EU AI Act, deploying ungoverned AI opens you up to massive regulatory fines. Ultimately, your AI is never going to be anything more than a reflection of your data governance.
So, here's our blueprint for today. First, AI runs on governed data. Second, shifting to real time. Third, the semantic layer. Fourth, AI-assisted data engineering. And finally, connecting agents to data. All right, let's jump straight into step one. AI runs on governed data, which is essentially where we pour the concrete.
To really understand how to build this infrastructure, we're going to use a blueprint, kind of like building a modern house. And right here, we are pouring the concrete. Large language models require incredibly high-quality, consistent data to actually function as reliable business tools. Without it, the house simply crumbles. You need automated data quality management to catch anomalies before they ever reach the model. You absolutely need metadata management. Why? Because if your AI gives a weird answer or hallucinates, metadata management gives you the lineage to trace that hallucination all the way back to the exact flawed spreadsheet that caused it. You've also got to implement bias detection to ensure your outputs are objective, right alongside rigorous privacy controls, like data masking, to protect sensitive customer info. This is no longer just standard IT housekeeping, folks. It is the absolute prerequisite for deploying enterprise AI.
To actually achieve that level of governance, we have to contrast the old way of doing things with the new way. Ungoverned manual data processing, which is basically the Wild West of data, where people just email spreadsheets back and forth, is incredibly risky when AI is involved. Instead, we really need to adopt the Analytics Development Lifecycle, or ADLC. Think of the ADLC as bringing rigorous software engineering principles directly into your data analytics. It enforces practices like version control and peer review. So, if an analyst accidentally renames a crucial column that your AI depends on, automated testing catches that error instantly, and the code just rolls back before it ever breaks your dashboard or corrupts your AI's training data. It guarantees that every single dataset your AI touches is trusted, tested, and totally verified. Moving right along to Section 2, shifting to real time, where we start building out the infrastructure. With a rock-solid foundation poured, we are finally moving away from the slow, manual batch processing of the past and building the high-speed plumbing our house needs. What you're seeing here is the modern real-time pipeline in action. It perfectly illustrates the extract, load, transform, or ELT process. In the old days, companies relied on slow, overnight batch jobs. If something happened at 9 a.m., you wouldn't even see it in your dashboard until the next day. Now, tools like dbt continuously transform raw data into analytics-ready models the exact moment it arrives in your data warehouse. You aren't waiting for a nightly update anymore. Your data is cleaned, tested, and ready for querying immediately, which is exactly how fast an AI actually needs to operate. And this incredible speed unlocks some really advanced architectures, specifically something called Lambda views. So a Lambda view is a pattern that seamlessly merges your deep, historical batch data with up-to-the-second streaming data. A perfect real-world example of this is JetBlue. They use dbt and Snowflake to combine massive databases of historical flight and maintenance logs with live, streaming sensors from their active fleet. Just imagine a mechanic out on the tarmac getting an up-to-the-second alert on their tablet because a live flight sensor instantly merged with a historical maintenance profile. It gives their analytics and any AI using that data a complete, unified, and totally instantaneous picture of their operations. Now, the return on investment for this kind of speed is absolutely undeniable. Take the global bank mentioned in our sources. They integrated dbt with Apache Kafka to process streaming transactional data.
In the old batch processing world, a fraudulent transaction might not get caught until a whole day later, and by then, the money's already gone. But by utilizing incremental models that only update new data, this bank was able to detect fraudulent transaction patterns instantly. We are literally talking about sub-second insights generating fraud alerts that save them millions of dollars annually. That is the staggering power of real-time transformation.
Okay, on to Section 3, the semantic layer. It's time to frame the walls.
Now that our foundation is set and the real-time plumbing is flowing, we need to frame the walls. This is where we ensure everyone in the house is speaking the exact same language. Look, we've all felt the pain of this scenario. Marketing reports that revenue is $1 million, but finance reports that revenue is $800,000, all because their underlying definitions of the word just don't match. If humans are confused by this, imagine an AI trying to pull data. It will fail spectacularly. A centralized semantic layer eliminates this chaos entirely. By defining your key business metrics as code in one central location, you ensure that every single dashboard, every report, and critically, every AI prompt pulls from the exact same mathematically consistent source of truth.
The impact of this centralization really cannot be overstated. Built Rewards utilized the dbt semantic layer to centralize their complex entity relationships, and by doing so, they completely eliminated a massive redundant step in their B2B reporting process. This single architectural shift resulted in an 80% reduction in their analytics costs. That isn't just a small optimization, right? That is a fundamental transformation of their business overhead. They slashed their costs while simultaneously skyrocketing the trust and reliability of their data.
Up next is Section 4, AI-assisted data engineering. Let's install that smart home tech.
With the structure built and the rules defined, it's finally time to install the smart home technology. This is where we start using AI copilots to drastically accelerate our workflow. Writing documentation and data tests manually from scratch is absolutely vital, but let's be real, it's soul-crushing tedium for engineers. Tools like dbt Assist use AI to scaffold this work for you, acting as a massive quality-of-life upgrade. It logically walks through your models. Step 1. It generates plain language documentation so everyone understands what the code does. Step 2. It automatically suggests and writes baseline data quality tests. And Step 3. It helps create the semantic models we were just talking about. It completely eliminates that intimidating blank page.
However, and this is absolutely crucial, the AI is an assistant, not a replacement. You cannot just blindly ship AI-generated code into your data pipeline. This ties directly back to the analytics development lifecycle we talked about earlier. Human engineers still have to apply their domain knowledge, run the peer reviews, and use the rigorous automated checks of the ADLC to verify every single output before it ever hits production. Basically, the AI makes you faster, but the ADLC keeps you safe.
And finally, Section 5, connecting agents to data. This is where things get really exciting.
Because wait, there is more. We are moving way beyond AI merely writing code for us. We're entering this cutting-edge future where autonomous AI agents read and interact with your data infrastructure directly. To understand how this works, we have to look at MCP, or the Model Context Protocol. It's a brand new open standard. Think of an MCP server like giving an AI a highly secure keycard to your company's data warehouse. Instead of a chatbot just guessing the structure of your data, the MCP server gives AI clients, like Claude or Cursor, governed, structured access to physically look at your models, your exact metrics, and your data lineage.
Because the AI now has the secure keycard access, the capabilities are mind-blowing. Imagine it's 2 a.m. and a critical data pipeline suddenly breaks. Instead of a human engineer getting woken up by a frantic pager alert, an autonomous AI agent steps in. It queries your semantic layer directly. It pulls the run details of the failed job, walks the precise lineage of the affected model, finds the broken code, and suggests the exact fix to the engineering team, all inside a single chat window. You're effectively shifting your project from static lines of code into a live, breathing infrastructure managed by AI.
And that brings us to our final thought for today. We've explored the entire blueprint. We've seen how to pour the concrete foundation with strict governance, speed up the plumbing with real-time processing, frame the walls using a centralized semantic layer, and finally plug autonomous agents directly into the system. But remember, the entire house rests on the underlying plumbing. Your AI is only as smart, only as fast, and only as trustworthy as your core data pipeline. So looking at your own architecture today, is yours really ready? Take a hard look at your foundation and let's get building.